My students, hope you all are fine. You are listening to your chemistry teacher, Ms. Hana Islam. Today we are going to study about chapter number 5, Physical States of Matter for ninth class. Our topic is Self-Assessment, Exercise 5.2 of your book. In this, you can see that a chemist obtained data in table 5.7 in an experiment at 1 atmosphere. As you know, ATM is the unit of atmosphere. In the given table, we have been given two conditions for a gas. First is the temperature and second is the volume. Temperature has been given into the unit degrees and volume in centimeter cube. In the temperature you can see first column 25 degrees and the volume increases 17.5. In the second row, the temperature increases up to 30 degree from 25 and the volume increases from 117.5 to 119.4. In the same way, third column, you can see volume increases from 30 to 35 temperature, whereas volume increases 121.3. And the last one, temperature increases from 35 to 40, whereas volume increases from 121.3 to 123.2. Now the question arises, explain volume temperature relationship using Charles' law. We have to prove the Charles' law by using these values of temperature and volume. So, here the first three steps are. Step 1 is, according to the Charles' law, you know students that the ratio of volume to absolute temperature is constant for any two sets of conditions. Now, step number 2 is convert the value of temperature given in degrees to Kelvin temperature by adding the value into the 273. And the step 3 or the final step is we have to find the ratio between the volume and temperature by dividing the volume by temperature for each set of conditions and compare. Now, let's compare it. First column, the temperature has been given 25, and as you know, we have to add this temperature value into the 273 to convert the degree value into the Kelvin. So, when we plus 25, when we add 25 to 273, we will get 298. So, in the last column, you can see the given volume, that is 117.5, when divided by 298, we will get 0.39. And in the respective rest of the column, you can see we get the same value of 0.39. It means that volume of a gas varies constantly with the absolute temperature. It means when we increase the temperature, the volume of the given mass of the gas is also increases, as stated by the Charles' law. Here Charles' law proved. Now we are moving toward the question number 2. A bacterial culture isolated from the sewage product 36 produces 36.4 centimeter cube. This is our first value of the volume, which has been given into the centimeter cube of methane. Methane, you know very well, a gas at 27 degrees. It is the value of the temperature as it is given into the degrees. And 760 mm of mercury, Hg is the symbol for the mercury. This gas occupies 33.124 centimeter cube at 0 degrees. Again, we have been given the volume 33.124 and temperature value, that is 0, under same pressure, that is again 1 atmosphere or 760 mm of mercury. So what we have to explain? We have to prove the relationship from this given data. Again, we follow the same rule. First is we have to convert degree value into the Kelvin value by adding the given value to the 273 value. And then in the last step we will find the ratio by dividing the volume by temperature. You can see in the first row 27, when we add 27 to 273 degrees we will get what? 300. So when we divide 36.4 by 300 we will get 0.1. In the both calculations you can see we get the same result. It means the Charles law is proved. When we increase the volume of a gas, when we increase the temperature of the gas, the volume will also increase. In question number 3, again we have been given a balloon which is perfectly elastic, and we will fill it with helium gas, and it occupies a volume of 1.25 into 10 raised power 3 dm cube, and atmospheric pressure is 1.00, and our temperature is 25 degrees. As you know, 25 degree is our room temperature. On ascending to a certain altitude where temperature is 15 degrees, the volume of a balloon becomes 1.208 into 10 raised power 3 dm cube. Shows that this data satisfies the Charles law. As you know, again, the ratio between the volume to absolute temperature is constant for any set of conditions. First, we will convert it by adding the value to the 273 degrees. And in the final step, again we will divide the given volume by temperature. And then in the last, we will compare the results. First, we will add 273 to 225. So we will get 298. And in the second step, when we add 15 to 273, we will get 288. When we divide in the first row, V by T, first volume is 1.25 into 10 raised power 3 by 298, we will get 4.19. Again, the ratio, we will get the same ratio, 4.19. Thus, the volume of a given mass of the gas varies directly with the absolute temperature as stated by the Charles law. Again, we have proved Charles law. Thank you so much. Stay blessed, my students. Take care. Allah Hafiz.